Okay, today we are going to review the notes that we took on Friday before we left on the 45, 45, 90 triangle. And I'm just going to start over because a few people weren't there and we could all use a refresher. So either take out the notes that were given to you that we started, or you can print a copy that I've uploaded to Schoology. But let's all follow along. Today we're going to do 45, 45, 90 only. So 45, 45, 90. Those are the measurements of the angles of a right triangle. So in this case, we call these special right triangles. The non-right triangles are both 45 degrees, which really makes it an isosceles triangle. And in an isosceles triangle, the sides that make up the legs, as you'll see right here, those are going to be congruent. So if they're congruent, we can call them both the same thing. We're going to call them X. I know we wrote congruent on here when we started, but today I'm going to have you write X. You can think of it as the side, and in this case, we don't know what the length of the side is, so we call it X. So if this is X, this is also X. What's really interesting about the 45, 45, 90 is that in every 45, 45, 90 triangle, when the sides are X, the length of the hypotenuse is X times the square root of 2. So I'm going to put that right here. So let's think about this. If this side was 5, the other side would be 5, and the hypotenuse would be 5 times the square root of 2. If this was 12, the other side would be 12, and the hypotenuse would be 12 times the square root of 2. So X just means some number, and I would plug that in. It's exactly the same or congruent for the opposite leg, and the hypotenuse is going to be whatever that length is times the square root of 2. You're going to hear me saying square root of 2 or root 2, and we're going to leave it like that. I want you to think of the square root of 2 almost like it's also a variable. We're not going to put it in our calculator and round to, a number very close to or round. We're just going to leave it as the root 2. So let's start. Let's take a look at this example 1. Now I know that we did this, but let's do it again. So in this case, I'm looking and I see that this side is 8. The two sides that make up the legs are always created by that right angle. So if this side is 8, this side is also 8, which means this side is going to be 8 times the square root of 2. So let's just write this down, make sure we have our variables right. This side's 8, so X is 8, and Y is going to be 8 times the square root of 2. Let's take a look at the next one. On the next one, we're given, well, let's take a look. These are the two sides that make up the legs. How do I know that? There's the right angle. It's formed by the right angle. It's an L, just like the legs are made up by the L. So if this side is 25, I see this side is 25, so that means the hypotenuse, which is the side across from that right angle, is 25 root 2. Sometimes I'll say root 2, sometimes I'll say square root of 2. So let's take a look here. We've got to be careful because sometimes they try to trick you. Here I see that the other leg is Y. So Y is 25, and X is 25 square root of 2. Now let's take a look at the next one. The next one, well, I'm looking here, and the L, or the legs for this right triangle, are X and Y, and they gave me the hypotenuse. I know it's a hypotenuse because it shoots right across from that right angle. So, how am I going to figure out what X and Y are? They're going to be the exact same thing. After we do one, we'll see that there's a shortcut. I know that the hypotenuse here is 19. But I also know, when I look up here, that the hypotenuse is equal to whatever the leg is, or X, times the square root of 2. So I'm going to say, well, this is equal to X square root of 2. I know that because that's right here. It was given to me. It's a special right triangle. Well, I want to get X all by itself. Anytime I have a number next to a variable, And in this case, a number next to a number that's in square root form, I want to get rid of it. They're multiplied because they're right next to each other. So to get rid of that and leave the x by itself, I have to do the opposite of multiplying by the square root of 2. So I'm going to divide by the square root of 2. That makes this go away because anything divided by itself is 1. So now I have that x is equal to 19 times the square root of 2. Now those people who were there on Friday, you'll remember I told you mathematicians decided we can never leave the root or a square root in the denominator. So in order to alleviate that, they do something which is called rationalizing the denominator. Let me show you how we rationalize this denominator. But once we do it, you'll see that there's a pattern. So if I go over here, and you can go over here right where we have our special right triangle box. If I have 19 times, or divided by the square root of 2, if I want to rationalize that denominator, that means that I want to get rid of this square root. It's always true that if I multiply anything by 1, it doesn't change that number. So I'm going to really multiply this whole thing by 1, but a special form of 1. I'm going to multiply it by the square root of 2 divided by the square root of 2, because anything divided by itself is 1. Well, when I do that, the denominator, well, the numerator is easy. I'm going to end up with 19 square root of 2. But my denominator, the square root of 2 times the square root of 2. If I put it into my calculator, I'm going to easily get an answer, but I want to explain it to you right now. The square root of 2 times the square root of 2 is really equal to the square root of 4. And the square root of 4 is, well, it's simply 2. So this ends up being 19 times the square root of 2 over 2. So let's put our numbers in here. I see that now both of my legs are 19 square root of 2 over 2, which is equivalent to 19 divided by the square root of 2. So now, let's do some examples. Let's turn our paper over and let's look for the ones that are 45, 45, 90. Now, I know we already did these, so if you want to turn this video off for a second and redraw that so that you have another example, now's the time, and then I'm going to begin talking about how we find x and y. So let's take a look at this first one, number 10. Number 10, oh, I skipped the bottom part. Let's go back, sorry. Backing up, back it up. No, I don't have any 45, 45, 90, so I am going to flip it over and go to number 10. Let's take a look at that. Well, I see that these are the legs. How do I know that they're the legs? Because they're formed by the L. They are congruent to each other. So whatever x is, y will be the same thing. They gave me the hypotenuse. How do I know that? Because the right angle points to it. So let's use the trick that we just learned on the page before, and that's whenever they give you the hypotenuse, in order to find the leg, you just multiply it by the square root of 2 over 2. So that is my answer for both x and y. X and y are both 28 root 2 over 2. They don't give us a lot of space here to write, but we get it done. Let's take a look now at number 12. Well, what have I been given here for number 12? Let me find the hypotenuse first. Oh, the hypotenuse is y. So that means I already know what x is, because these two legs are congruent. So that means if I go back to the beginning, let's take a look at it one more time. Given the side, it's easy. 8 root 2. So on this one, if this side is 4, this side is 4, and the hypotenuse is going to be 4 times the square root of 2. Well, let's make sure we get our variables right. X is the leg, so that's 4, and y is going to be 4 times the square root of 2. Let's see here. Let's do another example. I know that I did several of these with you right in class, unless you weren't there. Let's take a look at number 15. So number 15, what am I given? That's the first thing I have to ask myself. Well, I'm given the hypotenuse. I know that because the right angle is pointing to it. So given the hypotenuse, well, the hypotenuse is equal to whatever this leg is times the square root of 2. And I see that my hypotenuse is 9 times the square root of 2. So the number that's in front of that root has to be the length of the legs. Very easy. So that means both x and y, since they're congruent, are both 9. Let's take a look now. Let's do number 17 together. So for number 17, let's take a look. What am I given? Well, I'm given the square root of 10, which is the hypotenuse. I'm just going to mark it as hypotenuse is equal to whatever the side is times the square root of 2. So there's no number in front of a square root of 2. They told me that the hypotenuse is equal to the square root of 10. So I know I have to get rid of that square root of 2. I'm just going to divide both sides. I know why, because anything divided by itself is 1. So now I have the square root of 10 divided by the square root of 2. Now I could spend time rationalizing that denominator, but I have a calculator. And if you have one, now's a good time to take it out. You're going to need it probably for some of the practice problems that we have. And if you don't have one, you can use the one on your phone if you need to. So let's take a look here. I know that I'm going to turn this on and push the N over D button because that means numerator over denominator. I'm going to put the square root of 10, so second x squared 10 in my numerator. Then I'm pushing the down arrow and I'm going to put the square root of 2 in the denominator, so second x squared 2. And when I push enter, I get square root of 5. I'm not going to change that. I'm not going to push the double arrow button and get a number. I'm just going to say, okay, the answer, both the legs are the square root of 5. Now, if you look here, we have not had a lesson on rationalizing or radicals, but it actually is just divided by itself. But we don't need to worry about that. The square root of 5 and the square root of 5. That's what the legs are. So now, I'm going to take a look here at some practice problems. And these are the practice problems that I gave you on Friday. I don't know that we had time to finish it, but for today's lesson, your practice problems are going to be on the second sheet, which is called the homework sheet. I'm going to have you do problems 1, problem 2, question 5, question 7, and question 11. Those are 1, 2, 3, 4, 5 special right triangle problems only using 45, 45, 90 that I'm going to have you do for practice. Tomorrow, when I present your lesson, I will give you the answers to those problems and then give you the new lesson with more problems. Of course, you could just not do them and get the answers, but you won't be learning. You won't have the practice that you need to be successful. So that's it for this lesson today, and I will see you again tomorrow.